Good evening, ladies and gentlemen. Good evening, ladies and gentlemen, and welcome to another Wednesday night with Advisors webinar, Surviving the Pandemic. I'd like to welcome our guest from Moscow, Sergey Smirnov. Good evening, Sergey. How are you?
Good evening, Dr. Saadi. Good evening, everyone. I'm glad to be here, and I'm glad to welcome all of you to this webinar.
I'm very happy. It's the first time we host someone from Russia. Of course, it will not be the last. So you are our Russia ambassador tonight.
Yes.
Okay. Sergey, has over 20 years of experience working in telecommunication, working in technology, and I will start.
And once again, good evening, colleagues. And I want to say that I thank Dr. Saadi, Adra, and his team for their effort and for the opportunity to share my experience with you today. In the context of the COVID pandemic, it is becoming more and more important to have such platforms for communication of project management community members. And today we will focus on some of the specifics of project management in the rapidly developing and growing field of telecommunications in Russia. But before I begin, let me say something about myself. My name is Sergey Smirnov. I have more than 25 years of experience in fields of information technology in various roles. I have been working in telecommunications for more than 18 years, and I was engaged in business analysis, system analysis, architecture design, and direct software development also. I successfully implemented more than 60 different projects, and now I'm lead strategic transformation program in one of the largest telecom operators in Russia. The agenda of today's meeting will include three key elements. First one is a brief introduction to the current state of the telecommunications industry in Russia and its connection, both as a tool for implementation and as independent component of Industry 4.0. Second, I want to share some history of successful adaptation of the method of system engineering in solving problems arising in project management. And the last, a brief introduction to my personal experience of project management in Russia. Last one is the question and answer section. And before we continue, let's take a small vote. How old do you think the telecommunication area is? More than 5,000 years, from 250 to 5,000, maybe a little bit earlier than 100 or younger than 100. What do?
So as usual, I'd like to ask everyone, please, to make a selection at the poll. Not write A, B, C, D in the chat box, because there they will not be part of the statistics. Thank you. So if they stabilize, I'd like to stop it now.
I think it's enough. Okay. And we have 24% for A, older than 5,000 years. 14 persons for B, from 250 to 5,000 years, 34 persons for C, from 100 to 250 years, and 26 persons for D, younger than 100 years. In fact, the answer to this question largely depends on how modern we perceive the telecommunications. I prefer to think that telecommunications have become an integral part of human life since the time of human settlement on Earth. Indeed, the farther people were from each other, the more they need to invent a way to quickly transfer information between tribes or villages, especially when their fate could depend on this information, for example, notification of the approach of the enemies or a call for help. The first prototypes of modern telecommunication device were invented in ancient times when signal smoke or bonfires were used to transmit information in the territories of Lebanon, Africa, and Asia. A little later, on the territory of ancient Greece, for the first time began to use hydraulic semaphores, which, for example, were actively used during the First Punic War for communication between neighboring Sicily and Carthage. In more or less modern sense, the means of communication began to form about 250 years ago with the advent of the first telegraph and further the telephone. The explosive growth of communications dates back to the end of the 20th century and the beginning of the millennium. The development of mass internet and mobile cellular communications completely transformed the face of modern world. The current state of telecommunications in Russia is completely changed mindset and a new worldview. The ubiquity of cellular communications eliminated the overwhelming number of problems that existed during the Soviet era, when it was elementary difficult to contact a specific person, and communications were made by post, and in most cases with delivery time 5 to 7 days in average. Currently, the total number of active SIM cards for all cell operators exceeds the population of Russia. At the same time, the share of voice calls is constantly decreasing, while mobile internet consumption is growing. In almost all cities, almost all households are covered by home internet using FTTX technologies or alternative, for example, FTTB, like as fiber to the building. The internet channel, in comparison to the end of 20th century, has ceased to be an independent service and has turned in a certain sense into the same commodity service as electricity, water, or sewerage. It is funny to say that unlimited mobile internet for a smartphone or modem costs only $12 in a month, and unlimited internet using FTTB technology costs about $6 in a month. It's an actual price. Even taking into account not the highest average wages in Russia, everyone can get internet access in one form or another. If you make a comparison, it is easy to establish that Russia occupies one of the leading places in the world in terms of availability and variety of mass telecommunication services. In such conditions, the fight for the client and their money is conducted within the framework of additional services, useful content, and customer convenience, or it may be said customer experience. The client, in turn, has also changed the mindset completely and has become much more demanding and carefully chooses the best product or services that suit him. The price plan war is over. Here coming new era of information consumption, era of digital human being, the era when customers dictate what they want. If we apply a systematic approach and assess the current challenges of the modern human ecosystem to the mean of production, we can say that there is, first of all, exponential increase in the complexity of products, even for the simplest household use. For example, your phone 50 years ago consisted of dozen mechanical parts. Now it's a full-fledged computer with a voice call function. It's a computer. Next one is high speed of changing of the requirements for the target products. Short life of requirements. Requirements follows the fashion. And this applies to both devices and communication services and tariffs. Third one, the mass production and consequent mass requirements for the products that gives rise to a large variation in requirements. Each customer wants to customize and get its own version of product, have own view, own opinion about it. Here also we can state increased demand for the manufacturability, increased requirements for technological renovation, and more stringent requirements of the mean time before fail. Next one, as it could be stated separately, it's a product personalization requirement. 100 years ago, when you are going to buy a car, you can buy the car, black color, etc. Now you want to buy a car and you want to select gears, engines, color, transmission, etc. You are customizing your product. And it's your requirement as a consumer. And in this case, we need to state also that here exists a transformation and the pressure of new financial model. The financial model of production changed from owner to the investor, and the pressure of a financial market reduced the life of the product generation from decades to 6 months or a year. Now your product generation for the smartphone is 1 year or less, for example. Also, it needs to be noted a significant increase in the impact of the product price. On the other hand, it is reducing role of the human-machine interface and significant increase the prevalence and significance of the machine-machine interface. Current telecommunication industry, modern telecommunication, provides channels for devices to communicate each other. As part of such topic as artificial intelligence, trainable systems and systems making not algorithmized decision by the machine based on the analysis and statistics of perturbations, reactions, critical influence of the quality and volume of training. This means that if you create some complex system, but you didn't train it well, the result will be bad. Also, it should be stated some kind of ethical standard and support for the choice and decision-making of the machine in critical situations when any choice leads to the infliction of certain amount of damage. For example, if you review the idea of driverless car, then you need to understand clearly that in algorithms and the behavior of this car will include the choice in some incident or critical situation, but machine will decide which damage to treat as acceptable damage. In this case, we need to state that significantly increases the impact of the software quality. If the software have bad quality, we will have some kind of impact to the production, to the service, and to the behavior of intercommunication of or behavior of device. Finally, the technological impasse, the lack of unexplored opportunities in the existing technology will lead us to the need for the new technologies. And this is the way to create new tools, new answers, and invent new technologies in order to fulfill requirements of new work, like requirements of Industry 4. And to finalize the slide, I need to mention also the ecological compatibility as a challenge from perspective of new world. We have limited resources for production. We have insufficient and ineffective measures for utilization and ensuring the turnover of rare and expensive resources. The latter would seem to be of little use for telecommunications industry, but if you think about it, in the field of telecommunications, there are exactly same limited resources that are being fought for. These are the frequencies available for organizing mobile or stationary radio communication, including cellular communication. There are physical channels that, in conditions of dense urban development and extremely limited opportunities for laying them, require extremely careful and efficient reuse. This is telecommunications infrastructure that requires more equipment, more power supply, and more cooling. It needs to be said that already at the moment, the total energy demand of world's data centers, for example, is measured in several hundreds of terawatt. It's like 1 or 1.5% of worldwide power consumption. And in order to understand the role and impact of telecommunications and in face of such significant changes and challenges, it is necessary to briefly recall Industry 4 and its goals and main companies. Unlike the first, second, and third industrial revolutions that have already taken place, the fourth is not only about emergence of new technologies, but also about integrating existing ones into one system. So in cloud computing, in the IoT, in the virtual reality, in the field of information security, new technologies have appeared that have just allowed to achievements of last 20, 30 years to bring to real production, to make them available for wide use. All the pieces of the puzzle are already there. You just have to wait for them to put together in a single picture. But what are the main elements of fourth industrial revolution?
Yes, it's stabilized. It's over.
Okay. Okay. So we have 9 persons for flexible manufacturing, 12 persons for personalized offers, 25 persons for improved quality of life, and 51 persons for artificial intelligence. In fact, all the answers listed are correct in one way or another. But from my perspective, option C, improved quality of life, combines all the above and still unmentioned elements that have to be integrated to achieve the one most important goal, improving the quality of human life, to create conditions in which a person can acquire what he needs and not what is offered to him. Before moving to the impact of the principles laid down in Industry 4, as well as factors of the surrounding world on a project management in the field of telecommunications, let's briefly recall the main components of Industry 4. What is laying down in the basis of Industry 4? First of all, we need to recall the product life cycle management, PLM. It's an organization and technical product life cycle management system based on principle of object operation, physical information duality. Material and technical support, production, operation, disposal, and all related processes occur in the physical space. They correspond to the process occurring in the information space by using sensor, etc., occurring in computer systems. Therefore, for effective use of IT technologies, it is necessary to transform the processes occurring in the physical space into information problems, as well as to be able to reverse the transformation of information process into physical ones. The transformation should be considered as a problem of adequate modeling of the product lifecycle algorithm. For example, establishing a one-to-one correspondence between the physical and information space. Subject-oriented application software complexes, also known as project lifecycle management systems, are designed for structuring an area of data and automating the management of physical and information processes throughout the product lifecycle. Next huge company is big data, the quite modern company using modern technologies. A set of approaches, tools, and methods for processing structured and unstructured data of large volumes and significant variety for obtaining results perceived by a person or computer system that are effective in conditions of continuous growth and distribution across numerous nodes of computer network. Big data, first of all, it's a collection of data from traditional and digital sources inside and outside the company. Data is collected everywhere, from sensors, company employees, emails, communications channels, counterparty companies, customers, service centers, suppliers, etc. And then the data is structured, analyzed, and results are used. The main task of enterprise when working with big data is to best interpret the data for future use. Key characteristics of big data is volume, the amount of physical data volume, the velocity, the speed of data volume growth, and variety. Simultaneous processing of various types of data, structured, unstructured. Information-sensitive production system has the properties of avalanche-like flow. The amount of data is constantly increasing, and the variety of information is expanding. Managing, structuring, interpreting, analyzing, and using data is one of the most important tasks of organization production industry as part of Industry 4.0 principle. Next one is smart factory, smart manufacturing concept. Unfortunately, in Russia, this term is very often translated as smart production, although the shade of meaning is different. Thoughtful production is not required to be smart. It must meet the criteria of visibility. We could observe, could have clean answer to the question, what's happening? The clarity, we could have an answer to the question, why there? Predictability, we need to have an answer to the question, what happens? And self-correction. The self-correction is answer to the question, first of all, answer to the question, how to implement the self-corrective action. SMART is a mnemonic abbreviation used in management and project management. I would kindly remind it to you. S means specific, that explains what needs to be achieved. M means measurable, explains how the result will be measured. A means attainable, achievable, explains how to goal is planned to be achieved. R means relevant, determining whether the goal is true. T is time-bound, means limited in time. And the concept of smart factory based on seamless connection of individual stages or operations of the production process from the stage of product design and planning, the use of production resources to the actuators in the field. In the foreseeable future, the concept of smart factory will change significantly with the development of adaptive cognitive systems. The use of systems based on artificial intelligence in production will change production as type of human activity so much that new technologies for organizing production based on adaptive cognitive system that can be rightfully considered the first industrial revolution, and I hope we will discussion about it in 10 or 12 years from now. And the main role of man in Industry 4.0 is to develop algorithms and train machines using programming methods. We are switching out of direct production activities to training when the production activities will be made by machines. Next part here is CPS is a cyber physical system. Cyber physical system is an organizational and technical concept for managing information, integrating computer resources into physical production process. In such system, sensors, controllers, and information systems are integrated into a single network throughout the entire product lifecycle. A cyber-physical network can be either within a single enterprise or within a dynamic business model that includes several enterprises. Operations interact with each other throughout the life cycle using standard internet protocols for managing, planning, self-tuning, and adapting to changes. The Internet of Things cannot exist without cyber-physical systems. Since CPS, cyber-physical system, is an infrastructure of Internet of the Things. About the Internet of the Things, one of key and well-known items in the Industry 4. The Internet of Things is a simple definition of ground concept. IoT is a concept of computer network of physical objects equipped with built-in technologies for interacting with each other or with the external environment, which considers the organization of such networks as phenomenon that can restructure economic or social processes, excluding the need for human participation for some actions and operations. Today, for example, you can design parts at home and order their production over internet from 3D printers, 3D printers and other automatic production systems, in which a person plays the role of ensuring the performance of automatic production process, not the manufacturer. IoT connects things connected to the internet with each other and enables them to work together, managed by a cloud computing system. Internet of Things enables the interaction of physical production operations and related processes. Interoperability, kind of basement element. Interoperability is the ability of all system components to work together to achieve a single result. And the most important, it is the most important factor in the industrial concept of Industry 4.0. Without functional compatibility, it is impossible to create a workable integrated production system, Industry 4. Unfortunately, companies that develop automation systems have long developed their products without common standards, without taking into account the prospects of globalization and the potential integration needs of their customers. But now the strength is changed radically. Such significant changes requirements for the flexibility of solutions offered in the telecommunications sector, in fact, required from operator to provide services customized for a specific client, moreover, to identify clients' needs based on their behavior or available or acquired information, are actual signs on the basis of which the telecommunications sector can be considered as an independent component of Industry 4. On the other hand, telecommunications provide tools for industrial and manufacturing enterprises that implement the concept of Industry 4. The basic communication channels mentioned above between elements of enterprise system or the enterprise systems of systems, acceptable data about customers and their behavior, big data tools, and other tools that can be used by third companies for their own purposes. Thus, we can say that de facto, the telecommunication industry in its modern state at the moment is on the razor of Industry 4, being an integral part of it. I found interesting picture on the internet and would like to share it with you. This is visualization of something like Maslow pyramids of need in the context of digital world. And we can see that de facto we are talking about the implementing human needs using a certain set of tools. At the basic level of needs, we provide commodity services to provide access to digital world. Access means electronic devices, smartphones, laptops, etc. At the level of basic needs, we are talking about providing tools for online communications, some basic concept, certain professional services. At the level of physiological needs, tools are provided in the form of social networks and communications media. Each need has its own tool with which this need can be met. And modern telecom must respond to these new needs and create unique products personalized by the user, actually implementing the concept of smart factory, not only in the world of producing its own unique pair of shoes or suit, but in digital world. And it could be said that at the moment, the Russian telecommunication industry is actually actively developing such a concept as an ecosystem, a system of client-holding relationships in which the client can meet all or almost all of their digital needs. The ecosystem includes various elements of the telecommunication plan, such as contact, streaming services, communication platforms, messengers, etc. And on the other hand, we have some kind of elements from non-telecommunication world, like analytical contents, professional services, for example, insurance, telemedicine, or something like Uber for example, domestic workers, banking and payment services, universal identification capabilities, etc. As a result, the client gets the opportunity to build a package of services from the offered components that is necessary for exactly for him, for his needs, and not only build it, but also configure it for his own needs. For example, if I want to watch only HBO series and only on my smartphone, I can exclude all other channels from my package and optimize my costs, both material and technical. I don't need to pay for content that I don't consume, and I don't need to purchase and deploy some infrastructure elements like routers, etc. And this is the essence and the main result of Industry 4.0 for the end user. Flexible, lean production and delivery of what the consumer needs when the consumer needs it. Exactly when the consumer needs it. Now, let's take a look at the most interesting part, the impact on the telecommunication project. What new problems and tasks need to be solved? What are new approaches and methods can be applied? Since we're talking about IT projects, first of all, we are talking about upgrading existing and developing new components of the IT architecture of a telecommunication enterprise. The classical approach is to identify the needs of a business or a client, describe these needs in the format of formalized requirements, implement changes, integrate, and deploy. This can be implemented both in classic waterfall model and using, for example, rational unified process, or using flexible agile approach, for example, Scrum framework, Scaled Agile, disciplined agile delivery, and others. Depending on the volume and type of task being solved, it shall be taken correct applicable technology, applicable approach. Within the framework of Industry 4 concept, the telecommunication industry is facing a completely new challenge. Give a hungry man a fish and you will feed him for one day. Give them a fishing rod, teach them to fish, and you will feed them for life. To give the customer the opportunity to get the product they need on their own and teach them to do it. This is a modern need that requires a serious rethinking of approaches and recommendations and best practices that have been formed in the telecommunication industry for decades. Key elements of the implementation of this need are atomic reusable system components, means features that implement regular functionality, mid-level components that implement features orchestration to meet business needs, high-level components that create business value, business capabilities, tools and frameworks that allow you to not to lose breadth of task overview when solving specific problem, as well as manage the accuracy and reliability of the source data. As a starting point, you can try to study the terminology and recommendations of such standard as TOGAF, for example, the Open Group Architecture Framework, and Team-Forum Open Digital Architecture also. And all the above is subject to another extremely significant requirements. As soon as we talk about implementing project in modern telecom that meets the principles of Industry 4, we are talking about implementing modernization in the ecosystem, which implies a significant increase in responsibility for business continuity and service continuity. Indeed, if 10 or 15 years ago we implemented, for example, a new product on home internet, the worst thing that could happen is that some customers might become somewhat uncomfortable using some tools. For example, the user personal account would disappear for half of an hour. The provision of service was successfully detached from IT tools, and there was no question of building and providing services on the fly. Now, if we, for example, unsuccessfully modify an existing or implement an unsuccessful components of the landscape in terms of managing of subscriber balance, for example, or managing the subscriber payment, the consequences will be noticed by a large part of subscriber base, including partial loss of the ability to use the service due to non-payment, automatic blocking in case of negative balance, etc. That is, once again, we get a very strict requirements to ensure business continuity and service continuity for the client while implementing changes. At this point, we see a conflict between the need to implement new initiatives quickly and the need to ensure the continuity of the service. The role of risk of services interruption as a result of failed implementation increased significantly. That is the case. And to continue, let's make a small vote and determine your opinion of what are the key risks inherent in the project and the modern telecommunications sector. If we, for example, talking about Russia.
So, Sergey, you are asking about key risks in modern telco projects in Russia or in anywhere else? In Russia.
Especially in Russia. In Russia, of course.
But the audience does not live in Russia, most of them. So they are going to speak about the risks they see.
Let's imagine. They are professionals and they have an opinion. I think it will be a very good idea to understand their opinion.
Great.
I think it's enough. Okay, we have 4 persons for schedule budget, 9 persons for schedule budget and quality, 54 persons for schedule budget, quality and customer service disruption, and 30 persons for business targets and customer service disruption. I need to say that, unfortunately, I don't have enough experience in managing projects in other countries and other cultures, so it's quite interesting to me to understand the vision of the community. But for me, the answer D shows correspond to specific of project management in the modern telecommunication field in Russia. It is business targets and customer service disruption. Of course, all of these risks are important. They are encountered and they are more or less successfully mitigated. Timing and budget risks are absolutely standard and should always be taken into account. When executing project in the telecommunication field, you will rarely encounter a situation when you make a completely new product that doesn't affect the existing subscriber base in any way. And the risk of service interruption for some customers is very frequent and specific for all the telecommunication industry. But the most interesting risk, which is specific to the current state of industry, is inability to adequately involve stakeholders in the project. In this context, adequacy is understood as ability to get a clear vision from the customer of what should be the real result of the project, the result that is significant for the business. It can be assumed that the problem may be that classical education in both technical field and in the field of management and marketing is based on principles, methods, and approaches that are 5 or 10 years old or even more ancient. But the situation in the modern telecom has changed dramatically or significantly, and the value of the acquired knowledge about old approaches, needs, etc., has almost been reset. Over the past few years, the entire industry has actually exploded and completely transformed. Moreover, the transformation of needs is not over yet. It is, from my point of view, still in the phase of searching for the target state. And in this situation, the main stakeholders in the face of business cannot answer the key question: what will you sell in the future in next 3 to 5 years? As a result, there is a strategic uncertainty and project focus on achieving some clear technical changes rather than on achieving business goals, taking into account the prospects for real business development and threats both in the industry and related areas. This is the case. Maybe it's applicable only to Russia, I don't know, but actually I think that it's more or less applicable to worldwide telecom. Thus, we consider it key factors of influence specific to current state of the telecommunication industry. The requirements of flexibility for the client, the requirements of quick time to market, the abstractness of goal settings in terms of what is planned to sell, optimization of service delivery cost and cost of product, continuity of service for the client, and business continuity during modernization. And we also noted that there are certain contradictions between accepted methods of solution. It is necessary to combine the speed of changes and the reliability of implementations while maintaining the reasonable cost of implementing changes, the magic triangle. And in this context, it is interesting to look at the experience of hybridizing flexible project management approaches with system engineering methods, and we are moving on to the second item of our webinar agenda. In this part, we will talk about experience of adapting of some elements learned from systems engineering methods to projects in the field of telecommunications. I will allow myself to briefly remind you that system engineering is about how to create successful systems, while project management is primarily about achieving goals on time and within budget. System engineering is more about creating and validating requirements and verifying results and achieving customer satisfaction with both the project results and product received at further stages of its life cycle. Thus, combining or hybridizing the approaches and methods of project management and system engineering allows us to hope for a better result with the specified parameters meeting the criteria defined by the customer within the agreed time frame, within the established budget, in the context of poorly compatible requirements discussed above. In order to focus on further content and talk more specifically about the hybridization of system engineering approaches and flexible project management, let's remind and answer the question. Let's take a poll. What is system engineering for you? Okay, I think it's more or less enough. And we have 11% about A, 82% about B, and 6% about C. And in fact, the system engineering is a rather complex tool, and it's not applicable in all cases. System engineering requires certain formalism in setting tasks, planning, and recording results. It requires qualified resources that will perform functions similar to, for example, Scrum Master. It is labor-intensive and requires additional financial resources. At the same time, this method, which was born as a means of successfully achieving the result of major projects in the aeronautic and space industry, contains absolutely clear components, techniques, and tools that can be reused in the combination with components from other methods. As part of already tested hybrids, I would like to share, I would like to step into some kind of practical part. And as part of already tested hybrids, I would like to share a couple of successful stories of combining project management approach and system engineering method. In the first case, we are talking about a mechanism for checking the quality of requirements that are received in the input of analysis. The quality of requirements at the input to software development process, especially large-scale software, plays a crucial role, especially when proceed with fast development. Incorrect understanding of the requirements, misrepresentation or definition of done leads to increase in development time and potentially to errors in next stages of life cycle. In second case, the verification methods used allow to, in addition to evaluating of quality of the submitted requirements, it's useful to understand the degree of similarity between the requirements and thus provide the possibility of aggregation of requirements. In fairly large projects where number of incoming requirements is measured in thousands, it is impossible to have one analyst who, based on their own practical experience, could answer the question whether the requirement is similar to something previously discussed or implemented. It is important to note that for telecommunication industry that we are discussing today, it could be applicable to use such framework grew from system engineering method as TOGAF standard. For example, version 9 introduced very important concept for the lean development of the IT landscape of the large enterprise, such as capability-based planning. And in the latter case, we are talking about improving the efficiency and reducing the level of project failure due to rotation of project managers and team members through the support of Project Management Office for automated identification of project risks. Before evaluating the quality of requirement, it is necessary to formulate the criteria by which the assessment should be carried out. I will skip the explanation of the standards and will focus only on the criteria that have to be met for the software requirements specification. It's correctness, unambiguity, completeness, consistency, orderability or ability to be ranked, verifiability, modifiability, and traceability. And story number 1. The requirement specification must not contain design or implementation details other than known limitations. In other words, the requirements should answer the question, what should the system do, abstracting from the question how it should do it. And the desire to make detailed design decisions at the stage of requirements analysis is one of the typical pitfalls for inexperienced development teams. There are always more than one implementation options, and to make an informed decision, you need to know as much as possible. Therefore, the stages of working with requirements, design, and implementations are planned in turn, although they can be partially parallelized as part of an iterative approach to creating software systems. Based on the statement and based on description of quality metrics for the requirements that we stated in previously mentioned standards, we formulated a hypothesis that at high level, the quality of requirement can be assessed after the analysis of the requirement statement, which outlines the requirement. This hypothesis was confirmed as part of work performed in the Department of System Engineering of the Institute of Cybernetics. In this work, it was analyzed the wording of successful and unsuccessful requirements. It was formulated a list of words that characterize the requirements as successful or unsuccessful. Based on this, specialized software was developed that allows you to make an initial assessment of whether a requirement is high quality or not, and creates a report on requirements that don't look very good for making further decisions manually. This software was successfully tested for requirements analysis in a Agile project aimed to replace a software system for which expertise was completely lost. Preliminary requirements analysis were performed directly at the point of contact, stated in red cycle at the picture. In this point of contact, business and IT requirements were received at a change request. The use of semantic analysis tool made it possible to successfully implement the black box style system replacement in the dramatically short time. Only general principles of operations and specifications of interfaces were clear for the replaced system. And it have been exactly defined the predicted failure time. And such kind of preliminary requirements testing led to exclude complex and unsuccessful and unclear requirements out of the scope. Within the framework of mentioned project, the actual implementation period was short. Only 4 months passed from actual start of product and to practice launch in the new year period. And it will be honest to say that for the software with volume of 100,000 lines of code and hundreds of initial requirements, from my perspective, it's fast. And one of key optimization factors was the problem was a key optimization factor was that the problem of duplicate requirements was addressed to reduce number of requirements. In the development, it was in the development of semantic analysis performed in the previous example. It was implemented second step. In addition to the analysis of quality of requirement, through an assessment of formality of representation language and evaluation of how good or unsuccessful used words and expressions, there was a second stage. From a point of view of one second, I need to focus. Now, the second step is evaluation of similarity of wording of claims between himself and offering to unite with other requirements in order to reduce number of requirements. I will skip things that I plan to explain about how it were made, and let's just review an example. Initially, we have 2 requirements. That's first one on the left part of picture. The customer representative must be able to edit document at the approval stage. The second requirement, the head of division should be able to change counterparty at the approval stage. And the semantic analysis decompose the content of these requirements to some items and evaluate that similarity between these requirements are only 0.5. And if we, for example, get as input the requirement number 3, that head of the division must be able to change the counterparty phone number at the approval stage. The same analysis will lead us to the similarity much bigger, and we see that requirements 2 and 3 are much closer than requirements 1 and 2. And when we have much more 3 implemented requirements, you can already choose which implementation is more appropriate to refine to the desired functionality of new incoming requirement. And it's clear that use of proposed method for analyzing this similarity allows in particular case to optimize the effort of detailed analysis in a distributed team of analysts. And it helps to avoid case when, for example, 10 parallel commands and 5 of them works on the same requirement stated in different words. And the last of stories from my practice that I want to share. From my perspective, it's quite a good, successful story. It's a story about successful adaptation of system engineering standard 15288. And the case under the story is very simple. If you are an experienced project manager and you are working in the same enterprise for a long time, you're familiar with features of industry, company, etc., it's easy to you to identify standard risks when you're launching product. Completely different story when you are junior project manager or you came from different industry. In this case, the issue of identifying of project risks become much more complex. And proposed method is based on the ISO standard. ISO standard describes the process of system life cycle. And the idea is very simple. Using these described processes, activities, we create the life cycle of product, and as part of life cycle of product, life cycle of project. Each step of this life cycle filled with activities and process, and you have some kind of chain, fixed chain, where for each process by the configuration based on expertise, based on lessons learned, the PMO members could define associated risks that are standard for this exact activity, for this exact task. And when you create the chain of tasks, you automatically will get the list of standard risks based on lessons learned that could be useful for next mitigation and planning, etc. Now we finish it with a discussion about success stories. Hope that it was interesting for you. If you need some more technical details, please feel free to contact me, and we'll carefully discuss with you. And finally, when we discuss it with Dr. Saadi Adra, what it would be interesting to share with the community, I promised to tell a little about some specifics of project management exactly in Russia. And next slide is about it. I will be short. First of all, you need to say that size matters. If you're involved in the project in fairly large federal company, especially projects involving several branches, remote branches, project for construction of communication networks, gas pipelines, oil pipelines, other communication, then you are immediately faced to the huge size of the country. 9,000 kilometers from west to east and 4,000 kilometers from north to south. Different climatic conditions, etc. 11 hours of time difference between western and eastern branches, also the issue. Believe me, such distances and physical characteristics have an impact on everything. For example, if you try to create some, for example, a federal processing center, the simple question, how many processing centers do you have? And when you mean 9,000 kilometers, then you will easily understand that if your request comes from, for example, Far East, and the response comes from Moscow, The minimal physically achievable value is 60 milliseconds. In real world, in real networks, you will be you will have up to half of second or second. Will such system work? No. Next, let's say some words about issues. There are two significant issues that actually complicate project management. The lack of truly qualified managers who can make decisions and take responsibility for them, and the need to take into account the concept of path. The first is insufficient number of qualified managers, and unfortunately, the problem is systemic, and it's difficult, if not impossible, to solve it at the private level. We should start with the education system and vocational guidance. The second, the concept of path, is about the predominance of importance of doing something, moving, going somewhere, often to detriment of achieving the result. It becomes important not only to achieve the result, but also how it is achieved. From the point of view of project management, this requires additional efforts in planning and monitoring execution, as well as building communications. On the other hand, projects in Russia have absolutely wonderful enablers that allow you to implement a lot. At least in the field where I work with highly educated, smart people who are quite well or very well versed in the subject. People are motivated to achieve something both as a result of their activities and in their life. In Russia, IT specialists have very high level of qualification. They are able to solve problems completely non-standard methods, achieving result in absolutely impossible terms. To some extent, this is, so to speak, akin to heroism. And the last but also important advantage for my generation were tough to be universal soldiers. That is now to specialize in narrow field, but to have very good outlook, extensive theoretical training, and be able to do a lot of things with our own hands. Now I'm finishing my speech. Unfortunately, we don't have enough time, but I'm sure that if you were interested in the topics covered, we can prepare and plan some further webinars. And before we get to the questions and answers, I would like to express my deep gratitude to those people whose efforts was significant both in preparation and organization of the webinar and in creating the significant experience that I shared with you today. Of course, my great thanks to Dr. Saadi Adra and his team who organized this webinar and gave me an opportunity to share my experience with you. In the context of COVID pandemic, it's becoming more and more important to have such platforms for communications. I want to thank people who helped me discover systems engineering and adapt it to my professional work. First of all, my thanks to Mikhail Romanov, Director of Institute of Cybernetics, for the opportunity to conduct theoretical research in field of Industry 4.0 and adapt results obtained in practice as part of my PhD work. Thank to Anton Korolev, Head of Department of System Engineering at the Institute of Cybernetics, for the opportunity to implement the selected approaches of system engineering in practice. And my great thanks to Viktor Batovnik, an apologist, proponent, advocate, and facilitator of systems engineering in Russia, my teacher in this field, who discovered this wonderful approach for creating successful systems to me. I'm done here. Thank you for your time and attention, and we move on to the questions and answers section. Thank you.
Thank you, Sergey. It was really a fully informative session, lots of anchors and points. Now, before we start to take some questions and answers and do some discussion, Allow me first to inform our audience. I believe most of the participants know. Tomorrow we have an extra session. It's a panel, moderated by me as usual, led by Antonio Nieto Rodriguez. He has now results from his research done in collaboration between Harvard Business Review and himself for his own book. So tomorrow he is going to publish, but we cannot give the data to anyone. You can only attend. And his findings, how it fits with the strategy implementation professional. And we'll take the chance to welcome new professionals who actually earned the strategy implementation professional from Bahrain, Turkey, UK, and soon from Uganda. Now, this is tomorrow. I believe Mustafa shared the link if you like to register. Then next week, we're gonna speak about bid management and how it is very much linked and helps project initiation, especially from a contractor's perspective with Ahmed Khraizat, actually currently doing his doctor's study on the field, but he has over 20 or 25 years experience in the domain. And then I will be offering a talk with Badr Bourched. Badr Bourched is the president for PMI KSA chapter. He is also the leader for the Aramco Project Management Office department. He is one of the finalists for the PMO Global Awards experience. And I will be moderating the talk with him, so everybody's invited. There's also a link for those who like to attend, which is free of charge. Then there is also the IPMA Global Best Practice Week, the prestigious IPMA with over maybe 80 or 90 speakers. I will be speaking about surviving the pandemic strategy. I will be talking about our webinars. They asked me to present a case, and I happily agreed. So it will be also on the same date. I think maybe there's an hour difference between the two events. So, having said that, let's go to the questions and answers. So, Sergey, you spoke about multiple topics. One of the things you spoke about last with respect to the situation of project management in Russia. And you mentioned that managers are not that much qualified. And by managers, did you mean here sponsors or project managers? Sorry, you might be still muted.
Yeah. So sorry, I like to talk on mute. Of course, first of all, I meant sponsors managers, linear managers. Project managers in Russia are well experienced and do their job in correct way with all necessary efforts, etc. The issue is that while you creating new projects, initiating new project, while you executing project, you're getting some issues, problems, and you need to address it. And you need to have someone who could make a decision, not from perspective how I can solve this problem, but at least from perspective that we have a problem and we have, for example, possible solution A that will cost us plus 1 month in timeline and plus $1 million in budget, and possible solution B that will cost us plus 3 months in timeline and $10,000 in budget. Please select. Make a decision. And the issue is that there's not a lot such sponsors that could make such decisions and could make appropriate response.
Let me share with you something. This is not only rare in Russia, it is rare everywhere. We've spoken so many times before in so many different webinars about the scarcity of and the great need for project sponsors or directors, for people who actually have decision-making capability and know how to use it and have the enough commitment to use it for the sake of the project. One of the studies showed that 80% of project success or failure comes from these directors, not from the project managers. So when these sponsors or directors do not do their job properly, what will happen? Okay, the project manager will not be able to move on. He or she are stuck. Okay, and then they will be blamed for the failure that was caused by somebody on top of them that did not do his or her job properly. I have a nice story that I put in an article, which is called "It Takes Two to Tango." Okay, perhaps I will share this story later on, but it's one of the articles in my LinkedIn. It talks exactly about the relationship between the sponsor and the project manager. Each time the sponsor, because of his lack of decision making or not knowing what to do, project fails, he kicks away off the poor project manager, and then looks for a new victim. And the story is repeated over and over again. Now, another point that I like also from your last slide, which is the universal soldier. I believe tomorrow, Antonio is speaking a lot about this. He's going, but he does not call it universal soldier. Maybe this is a Russian term. He calls it the generalist. Okay? That the project manager needs to be a generalist. Look at the holistic aspects. Okay. Nowadays, it is we need the generalist because we need more integration, more collaboration. Okay. Technical aspects have never been the problem. We can always, and we have been always capable of resolving technical problems. And one of the best proofs to that is that in no time, the digitization or digitalization, we all became virtually enabled and started to work and to provide consulting and training and kids in school learning online. And the whole world is became very close to each other that maybe before Corona, we could not have the chance for us to, from somebody from Russia, another person from Middle East, from Africa, Latin America, East, all together.
Corona is opportunity.
So, very interesting.
Okay,
you finished with. You have some notes on that.
Okay. I just want to recall some part of, as part of discussion about the role of directors, etc. In the presentation, I told that one of key challenge of modern world is transformation of financial model from the owner of business to the investor to business. This means that most of these directors are just temporary managers. They have their own KPIs, and the issue is very simple. They work to fulfill these KPIs. They work for 2 years or 3 years. They don't spend tens of years in one company. This became an issue for whole company and for project management also.
Okay. Now, I have a couple of questions, but I just saw new questions based on this discussion. Sergey, your colleague Sergey Volchkov is asking, can project managers make decisions in Russia?
From my perspective, project managers could make a decision only in the boundaries of their own responsibility. If you try to ask about making more global decision, you need to become a product owner who is responsible for the product, how it creates, how it runs, what is revenue, what is cost for these products, how it shall be developed, and how it will be utilized. And this will enlarge your boundaries, and you could, in this case, you could participate both as project manager implementing projects for your product and make a decision as product owner within dedicated budget and within dedicated goals that will be enterprise goals, like efficiency, like margin, like revenue, etc. So you need to understand what do you want.
So Samir bin Muhammad is asking also on the same topic, what is the solution? Should we have a certificate for the sponsors in project management? And I have a couple of ideas around his question, Samir's question. First of all, there is a certification for sponsors by APMG. I never heard about it, but lately I've been working with APMG a lot, and I found they already have a certification for that. Imagine. The problem is that it's not about certification. The problem is that most of the C-level or high-level people, they rarely attend training or even accept coaching for many reasons. One of the reasons, they are busy. Another reason, some of them, not all, they have big ego, okay? As bigger than Eiffel Tower, maybe as big as Burj Khalifa. Because they are managers, they do not need to learn anymore, and they can just give commands and tell people. And if something went wrong, it's always somebody else's problem and somebody else's accountability. And I believe this should be outdated with the new technology we have today, this type. Nevertheless, we are in a transformation. We still have a lot of these people, they have power, but slowly they are being replaced with a newer breed that actually makes decision and focuses on business value, okay, on results, the things you started with speaking about in the beginning. You have an idea about this before I ask you the next question?
I think nothing to add. You defined everything quite well.
Okay. Now, Nabil Farhat is asking, with the acceleration, will systems produce digital systems of their own, and how can we control this type of world? It's I think the same question about AI. When does AI become, as some might say, independent? Okay, and you do software engineering, so I believe people who know software engineering and who know the techniques of AI, okay, it's not a philosophical thing; it's a factual thing. Computers will never have awareness, human awareness. They can have smart algorithms, big data to manipulate, to generate maybe new algorithms, but they don't have the conceptualization or the awareness thing that human beings have.
Of course, we need to clearly separate the term of artificial intelligence from perspective of scientific concept, like something like human brain, something like human being, could be said mindset or thoughts, and the tools that we are using practically now more and more and every day, that helps us to choose someone, helps us to identify some things, to do something quickly, to, for example, render pictures and make effects on your photo and video. It's also some kind of artificial intelligence processing algorithms. And we need to understand clearly these are two quite different things. I don't believe actually in something like
the Terminator.
Terminator, yes. I don't. Oh.
Yeah.
Robotized armors and robotized tanks, robotized airplanes. Yes, okay. We already have it, but it's not an artificial intelligence. It's quite a method or tool to minimize real combat losses. Yes, in terms of high cost combat specialists like soldiers. In modern war, soldier is a high cost resource, and we need to keep it. Each device costs which high costs, but actually costs much lower than to prepare and create new soldier. That's it. So I don't believe that we will be under full control of some kind of worldwide artificial intelligence. But I quite believe, or a strong belief, that the information about us and our behavior will be more or less public and will be used by some enterprises and other production facilities to identify our needs and to produce for us things that we are that we want, highly customized or personalized exactly. This is a way to artificial intelligence tool.
You are talking about the Social Dilemma movie by Netflix, if somebody watched it, which speaks about how we become the commodity. Okay, if you're not paying for it, you are the product being sold.
Yes.
Yeah.
Okay.
So last question from Munir Jode from Canada, our friend. He's speaking as per Industrial 4.0 timeline from 2009 to 2051. It was expected to launch 6G within this period, and second wave within time of 2016 to 2023. So how do you describe the world response in terms of readiness and awareness, and are we slow in a slow mode adoption?
From my perspective, it's not a question of slow mode adoption. From my perspective, the technologies are more or less on the same page as the need for these technologies. To be honest, I don't know how to utilize. I'm working in telecom. I am inside the telecom, and I'm personally don't know how to utilize 5G. Yes, because personally for me, maybe I'm from medieval ages, but personally for me, it is enough 4G and the content that I could get using the 4G. The concepts of next generation of networks will follow to the need of people and nothing more. The technology And such expensive technology will never born before it really needs. Such as practical pilot zones, yes, okay, we could do it. But actual deploying, no. So from my perspective, it's not a question of adoption or slow mode. There's no need yet.
Okay, Sergey, this was all. I thank you for being with us tonight. And I look forward to having you with us on other webinars in the future. Thank you for being with us tonight. Okay, and I'd like to thank everybody. Wish you a happy night, stay safe. Let's see you tomorrow night at 8 GMT plus 3, not 9. Then the next Wednesdays will go back to the 9. Until then, stay safe and bye-bye.
Goodbye all. Have a nice night. Thank you.
Bye-bye.